Welcome to the presentation on designing for fault tolerance. Today we will explore how to ensure system resilience and availability in the face of failures. Let's begin by understanding what fault tolerance is. Fault tolerance is the ability of a system to continue functioning even when one or more of its components fail. It is crucial for ensuring high availability and minimizing service disruptions, making it a key principle in reliable system design. Fault tolerance relies on three key components: redundancy, failover mechanisms, and disaster recovery. Let's take a closer look at each of these. Redundancy is about duplicating critical components in a system to avoid single points of failure. There are different types of redundancy. Hardware redundancy involves having backup physical components like servers or storage. Software redundancy involves running multiple instances of software to ensure uninterrupted services. Data redundancy stores copies of data in multiple locations, safeguarding against data loss. An example of redundancy is RAID, or redundant array of independent disks. RAID combines multiple disk drives into a single unit and ensures data protection in case of drive failure by using various redundancy levels. Failover mechanisms automatically switch to backup systems in case of failure. There are two main types of failover: active, passive. One system is active and the other is on standby. Active. Both systems are active and they share the load, ensuring no downtime. Consider a database system with failover. The primary server handles all requests while the passive replica remains idle. In case the primary server fails, the replica automatically takes over to maintain service continuity. Disaster recovery involves strategies for recovering from catastrophic failures. Key elements include a backup strategy that stores backups in diverse locations, RPO or recovery point objective, which defines the maximum acceptable data loss, RTO or recovery time objective, which specifies how long the system can be down before recovery becomes unacceptable. Disaster Recovery as a Service (DRaaS) provide cloud-based services to ensure fast recovery of services and data. With DRaaS, businesses can quickly restore critical systems and minimize downtime following a disaster. Regular testing of disaster recovery plans is essential to ensure that the system can be restored efficiently. Testing can involve tabletop exercises which simulate scenarios to practice response strategies, simulation drills which test recovery procedures in real time, full scale recovery testing which validates the complete recovery process. In fault tolerant system design, several design patterns are essential for maintaining system stability. The circuit breaker pattern prevents cascading failures by halting requests to failing services. The bulkhead pattern isolates components to prevent failures from spreading. The retry pattern attempts failed requests again. The fallback pattern provides an alternative response if a service fails. Continuous monitoring and logging are critical for early fault detection. Tools like Prometheus, Grafana, and the ELK stack help monitor the health of the system and trigger failover mechanisms when necessary. Monitoring ensures that the operations team is alerted to issues before they escalate. In conclusion, fault tolerance is a key aspect of modern system design. By incorporating redundancy, failover mechanisms, and disaster recovery, systems can continue functioning even in the event of failures. Regular testing and monitoring ensure that systems remain resilient and operational at all times. Thank you for your attention. If you have any questions, please feel free to ask. I would be happy to clarify any doubts.